involving food webs. All right, so as we talked about on Friday, a food web is basically a whole bunch of interconnected food chains that sort of gives a much more realistic view of the ecosystem, because most species eat several other organisms for food. A food chain sort of just makes it very simplified, that one thing eats another, which eats another. And then we concluded on Friday by talking about this energy pyramid. And we're rushed for time, so I want to make sure I explain it again. In any ecosystem, the most common organism, the most abundant living thing, is always the producer. If you think about any ecosystem, think about what kinds of things there are. There's always the most producers. They are the base of this pyramid. And then, as we move up the food chain, we get fewer and fewer and fewer of each organism. And if you think about huge, big carnivores, the top carnivores in an ecosystem, if you think about like a shark in the ocean, how many sharks are there?
Lots.
There are?
Yeah.
Are there schools of sharks swimming through the ocean?
No, but there's a decent
No,
amount.
they are relatively solitary. One shark covers sort of a very wide range of habitat because, again, they're at the top of the food chain. There isn't enough energy to have, groups of hundreds of sharks living together. Think about like a hawk. Do you see flocks of hawks like you do crows or something going through the sky? No. You see one hawk, you see a couple hawks. There are not that many of them. Think about a grizzly bear. You don't have a big pack of grizzly bears roaming through the woods together.
Yes, they do.
You have small numbers because they are those top carnivores. And then the reason for this, whenever one thing eats another, there's only about 10% of the energy consumed can be put into making that organism. So if we look at this ecosystem up here, there's lots of plants in the pond. When the shrimp eats the plants, only about 10% of the energy actually goes into making more shrimp. Then when the fish eats the shrimp, same thing. Only about 10% of the energy goes to the next level. And when the egret eats the fish, again, only 10%. So every step along the way, you're losing 90% of the energy. And therefore, you just cannot support very many of those top carnivores.
So nothing happens to the 90% of energy? Like what happens?
It gets used up as creating body heat for movement. It gets used up not into making like the fish bigger or the fish reproducing more fish.
Oh,
it's
so
still used, but it's used for other things rather than the population.
So 10% is really just a big thing.
Yeah, 10% can go into making the fish bigger
Okay.
or helping it reproduce more fish. 90% just gets used up. You could think of other ecosystems. Think about it in an ocean ecosystem. The most abundant, so the sun's energy shines on the ocean. Okay, tiny little plankton can use the sun's energy. There are billions of them in the ocean. They get eaten by little tiny animals, and there's fewer of them. And then they get eaten by fish, and there's fewer of those. They get eaten by even bigger fish. So there's even fewer of those. As we move up this food chain, we get fewer and fewer organisms. Okay? Because each step along the way, energy is being lost. We often can show this. Here is another ecosystem. We have an energy pyramid. On the bottom are always producers. If you think about it in a field, you're going to have the most plants. Grasshoppers might be the second most common. They're herbivores. There can be a fair number of them. And then animals that eat the grasshoppers, animals that eat those animals. Yeah, you think about that. You don't see lots and lots of snakes, around when you're walking through the forest. You might see one here or there because they're one of the top carnivores. There's not enough energy to support a huge group of them. So in this energy pyramid, what's happening? Energy is being lost. What is this? What would you call this? A food web. Okay, this food web, you could identify many food chains within this food web. Plants, the squirrels, the fox. You'd say plant, the grasshopper, the frog, the snake, the owl. That's another food web. In this ecosystem, which organism would you expect there to be the most of? In this ecosystem, what would there be the most of, Howard? These plants. What do you think there would be the least of? Dano?
The owl or the foxes?
Yeah, the owl and the fox. And that should make sense with your everyday experience. There's just not a lot of those big carnivores. And again, you see this here. Plants, the grasshopper, the bird, and the owl. Okay? Oh. All right, you guys have this one. Yeah, it's out of order, but that's okay. So if you look at this cute little bunny rabbit, what would you call the rabbit? What are some words we can use to describe the rabbit? Matt?
Consumer.
It's a consumer.
You gave us all the answers.
What else would you call the rabbit? What's another term? CJ?
The
What?
never mind, no.
Another word for the rabbit.
A herbivore?
It is an herbivore. What's another word for the rabbit? Another synonym for consumer. Danielle?
Rabbit?
No, something. I want to know another word for it.
Oh,
Consumer.
Oh, I was gonna say hare.
Haley? Heterotroph. Yes. All those words would apply. How about the tree? What would you call the tree? Danielle?
Producer.
It's a producer. What's another word for a producer? Brianna? Autotroph. What would you call the fungi? Kristen? A decomposer, yes. Want to give you those?
Yeah, you did.
All right, here I have another food web. And this is an aquatic, sort of a pond food web probably. Or actually maybe.
Like a river. Or a lake.
So, how is a food chain related to a food web? Alice? Yeah, they both show producers because they show what eats what. And a food web is made of many different food chains connected. And in an ecosystem, the ecosystem will be most healthy if it has a very complex food web. Why is that? Why is it better to have a complex food web than just a simple food chain in an ecosystem? Holly?
So that nothing dies out and everything is level in numbers.
Yeah, because if one species dies out and it's a very simple food chain, what happens to the other species? They die out. But in a more complex food web, if one species dies off, what could happen?
Another species could be found to eat.
Yeah, there's other food sources available. Right? So there's more choices.
So is that like the menu?
Sort of.
Shouldn't we be on here or no?
So again, all organisms eventually die and are decomposed. What if there were no decomposers in the environment? What if there were no fungi and bacteria? Yeah?
Then like all the dead bodies would just stay.
Yeah, we'd be like up to our necks in dead squirrels and stuff. Because they wouldn't be broken down and the nutrients wouldn't be returned to the soil. And that's a problem. Well, what happens if all the producers were to become extinct? Alex?
All like everything you could serve off, like The consumers would be thrown off.
Yeah. Basically, nothing would survive because everything eventually depends on the producers. There's no producers, there's no herbivores, there's no carnivores. So without producers, an ecosystem cannot exist.
Wait,
Okay. One more slide today. We have another food web. Again, this is a maybe a forest ecosystem. So in this ecosystem, tell me what are the producers? In this ecosystem, Matt?
Grass.
Yeah, anything else? Matt?
The green plants.
The grass and the bean plant. What if you didn't know what grass was and you just saw it? How would you know it's a producer?
Because it's green.
What tells you that it's a producer from a food web? Kristen?
It looks like something that's would come out of the ground.
All right, but something else, Nate. So what do you notice in the food web? There's no arrows pointing to it. It doesn't eat anything. The arrows only go away from the producer.
Don't they eat nutrients?
That's not considered eating something because it's how do they get energy? And they get it from the sun. All right, what are the consumers in this food web? Tommy?
The fox, the human, the fish, and like everything but the.
Yeah, basically everything else. The human, the fox, the fish, the rabbit, the bacteria. I didn't list them all, but everything other than the grass and the bean plant. Hannah?
I think if I didn't know what grass was, I would think it was something like a rock and not living.
Yeah. How about decomposers? Haley? Bacteria. What about autotrophs? What are the autotrophs in this food web, Olivia?
They make an
But what are the examples in this food web?
grass.
And?
Green plant.
Yes. It's the same as producers. What about heterotrophs? Dan, O?
the rabbit,
Yeah. All those other things. Who could give me a food chain that you could see in this food web? One food chain out of this food web. Anna? I just call it nice. I keep saying the same people. How about some new participants?
Dave.
Chloe.
Yeah, go Chloe.
What? So if we start with the plants, give me a food chain that's based on that. So let's start with a bean plant. What do you say?
Rabbit. Yeah, rabbit.
Okay. So bean plant to rabbit to what else?
Ew, people eat rabbits. People.
Fox.
Yeah, people eat
All right.
rabbits.
Anything else?
Anything that can.
No, that's where it ends. So that would be one possible food chain. Here's another one. Bean plant, rabbit, human. Grass,
Why
caterpillar,
humans?
fish, human. That would be another one. Now, what happens when you remove a species from a food web like this? Tommy?
Other species.
Yeah, other species are affected. Good. Yeah. If, for example, if we remove, what if we remove the hawk? what is something that might happen in this ecosystem? You remove the hawk. Matt,
The frogs would overproduce.
the frog might overproduce. The rabbit might overproduce. Then what would happen?
Then there would be too many of something and it wouldn't eat the other thing.
There's too many rabbits.
Overpopulation.
What's gonna happen?
The bee plants are going to die.
They might eat all the grass. They eat all the grass. Maybe the caterpillars then have no food. So
Unless you have.
removal of